Hey guys, let's talk about functional isomerism. Functional isomerism is observed when we have two compounds with same molecular formula but different structure, and the difference in structure is due to presence of different functional groups. That is, the connections this time between atoms are such that we have two different functional groups. So for this kind of isomerism to be observed, we must have functional groups, and that means it is not observed in alkanes because alkanes do not contain any functional groups. Now compounds of a certain class like alcohols have functional isomers of a certain class, that is ethers. So we have a fixed relationship about which functional groups have which kind of isomeric functional groups. So let's take a look at the pairs that we have. Alcohols will have functional isomerism with ethers. Aldehydes will have functional isomerism with ketones. Keep these relationships in mind. Acids, carboxylic acids, can have functional isomerisms with esters, right? And amines, like 1-degree amines, can have functional isomerism with 2-degree amines or 3-degree amines. So let's take a few examples based on functional isomerism and try to understand this concept even further. We have taken ethanol for example, and I am going to try to write its functional isomer, and for that I am going to change this functional group. That's right, functional isomers have different functional groups, so the trick is to change the connections to change the functional group. So what I am going to do is I am going to keep the molecular formula same, but we are going to reorder the arrangement of atoms. Now oxygen here can form only two bonds, and in this example it has made a bond with a carbon atom and another bond with a hydrogen atom. So what I can do is I can change only one of these connections, and that is the connection between oxygen and hydrogen. And let's replace this hydrogen atom with another carbon, and what we will have is carbon, oxygen and carbon. Why didn't I replace this carbon with a hydrogen? Because if we did that, we would get HOH, that is H2O, and there will be no more possibility to add other atoms. So what I did was to replace the hydrogen with a carbon. Now the remaining hydrogen atoms can be attached to these carbon atoms, and you can get CH3 and CH3. So we fulfilled the valencies of all the atoms in the compound, and we have changed the functional group. From an alcohol, we have changed this compound into an ester. So alcohols and esters are functional isomers. Here is another example for you. We have propanol. It is an aldehyde. So we write an Al at the end of the name. And the functional group for this aldehyde is CHO. Once again, to write its functional isomer, we have to change the functional group somehow. So look at this functional group first. It has a hydrogen atom attached here and a carbon atom on this side with two hydrogen atoms followed by a CH3. So what we can do is replace this hydrogen with another carbon atom, and we can modify this functional group as C double bond O and attach carbon atoms to both sides of that group, and we can get this compound, which is called acetone or propanone. So what we did was we changed an al, that is an aldehyde, to an one, which is a ketone. So aldehydes and ketones are functional isomers. So all you have to do is remember a few things, and that is alcohols are functional isomers of ethers, aldehydes are functional isomers of ketones, acids are functional isomers for esters, and amines are functional isomers of other amines with different degrees. In the next video, we are going to talk about metamerism. So stay tuned. Bye.